Hello everyone, welcome to this tutorial. This is in line with our last Saturday workshop on designing the interior objects and then also interior design elements. So I decided to record this from scratch again one more time for the people that they didn't get a chance actually to go to that workshop, or people in the workshop needed to catch up with some of those areas that we needed to go fast forward. As a kind of recap, if you remember, and you know about like some of the parametric lamps and then chairs, benches. So we discussed those in more detail. What are the features and then what we're doing with these kind of design. But spending no more time on the introduction. So we would like to do something not exactly that you're seeing in the picture, but in a different way, and then also with different settings and then controls on the geometries. As you're going to learn the principles, you can do more of the different types of exploration, and you're going to see as soon as you're going to get familiar with these kind of exploration, the ones that you can find them in industry, it's going to be easy to execute, and then you can write your own definition with the creative in the creative way, and then with creativity actually. If you don't remember, or you were not in the workshop, so and we're going to have like one profile of the lamp, and then based on that we're going to work on some transformation, and then ways that we can use for the transformation of the geometry, and then also those transformation, basically they're like rotation and then the scaling, but how we're going to control those, you're going to see, just like different ways that you can do that, and then you're going to learn during this tutorial how you can manipulate these geometries, and then you can get to the different types of really interesting actually form for the lamps that you're designing. And then let me rotate this also, because I remember that we have like in here also, let's see that rotation, yes. So those are the transformation that we're going to test in here and we're going to use. So let's just start from the beginning one more time, and then walking through this very interesting tutorial. All right. Alrighty, starting from a scratch. So we're gonna have like a circle, and then that circle is gonna be a circle based on the center, and then radius, and then center, as you know, that we're gonna use like 0, 0, 0 on the default center, which is coming with the same plane that we have, and the same construction plane by default is gonna be based on the X, Y rolled construction plane. So we're gonna use a radius of 10, and you can change, and then you can just like use difference in a number, but right now we have a kind of just like set up as for the sizes and the proportions, so we're going to follow that type of thing. So I have like the setup and the definition in here, but that would be actually it kind of just like a pattern that I'm going to use just to make sure that we're going to get at a kind of good proportion. So we're going to divide our circle, and then that's the curve, and then I'm going to use like division as for the number. It's going to be 5. You can set up this number between like larger than 2, because eventually we don't need 0 and 1. and then 2 is going to be the smallest number that you can use actually for this. Otherwise, you're going to have like some type of errors in here. So it's going to, the minimum is going to be not negative, it's going to be positive 2 actually. So and then now we can see that it's starting with 2, setting at 5 would be good. And next step is going to be the scaling part. So we would like to scale to get the inner or outer type of shape. So we're going to use the scale as a 2D scale. And then you remember double click and then type the scale. So you're going to get this. And then what we're going to do, we're not going to use the center because center is going to be corresponding with 0, 0, 0. And then I'm going to put this on like the scaling factor. And the number slider that we want is probably between 0.3 and then I'm going to put it on 0.5 to stay on 0.5, and then 1.4 would be good. So scaling a little bit larger than what we're seeing actually in here as the outer parameter of our geometry. Yes, we cannot scale points, but in here is not scaling the point per se, is scaling the location of the point. So that's very interesting actually. As you can see that we have like the scaling factor and it's getting bigger and smaller. So now we have a really interesting, just like way of dealing with that. So I would like to put it on 2-digit, the scaling, to get a little bit, just like a smoother sort of movement. Okay, so and then in here, as you remember in the past, so we discussed this, we have like 1, 2, 3, and then 4, and then 5 point. Then we have like other 5 point inside or outside of this. Then we would like to rotate these in the way that they're going to be, they're getting a kind of distance from the original point. That way we can connect these points and then making a really interesting form of the outer boundary of our shape. Sorry about that, just like I know I don't have my drawing pen and a sketch, so I know it's not really good, but I'm going to show you in a second, and then we'll follow each other, and then we'll see what's going to happen in here. So we're going to have like the scaling factor, and the rotating factor in here, and then that is rotate. There are different types of rotation, so we're going to use the single 2D rotation in here, very easy. So the plane, which is the centroid for that rotation, is going to be the same. We wouldn't just like change that. And then as for rotation, I'm going to put it between something like -50, put it on 0, and then positive 50 degree, and then like this. So you're gonna make it kind of a slider in here. So those are the numbers. You can change the number digit, so you can put it on 2-digit or 1-digit if you wish, doesn't matter. And then that would be the angle, but the angle is based on the radiant. So I would like to change this to the radians, and then so you have like the degrees, and then you're gonna get the radians in here. So radians in here, or you can do some of the things too. So another way is changing this by clicking, right click on angle, and then change it to degree. So I'm going to show you this way also. You're gonna learn this way too. And now we have like the rotation both ways, either way that we want. So again, and it's going to be 50 degree. Of course, that we need to make sure that those number that we're going to use is not going to path each of these increments, meaning that point number 1 is not going to pass point number 2, then you can easily divide 360 degree by the number of the section that you have in here. So 1, 2, 3, 4, 5, 360 degree divided by 5. So the number shouldn't be larger than 360 divided by 5. So 360 degree divided by 5, I guess it's going to be 72 degree. So I'm not sure, but yes. Anyway, so that would be the number for that for this slider that you're going to use. Otherwise, you're going to have like probably some funky shapes. We'll see that in a second. Anyway, so let's turn off these scaling scaled geometries. We don't need those. So if you remember, it's control space, and then I'm going to also turn off this circle from the beginning too. So now I have like the series of the first series of the point, and then second series of the point after scaling and then rotating. So now I'm trying to connect point number 1 of the first series to point number 1 of the second series of the points, meaning that I'm going to have like 2 lists, and then I have like 1 list in here, and then these are the list of the points, 5 points in this case because I'm using number 5, and then meaning that the indices that I have between 0 and 4, and then also the indices that I have between 0 and 4. So now I need to weave these 2 lists. Otherwise, if I'm going to use the polyline, then the first list is going to be connected with polyline, all those points, and then it's going to go after the second list. No, I don't want to do that. I want to connect 0 from this list to 0 from the second list. The 0 from the first, 0 from the second, 1 from the first, 1 from the second. So that's that kind of order that I want. So now I'm going to use weave as a as another component, and then the pattern by default actually is 0, 1, meaning that it's going to list 0, then it's going to go to list 1, list 0, list 1. And then it's going to repeat this as long as the list is going to get exhausted. So you're not going to have anything to include to this. So what I'm going to do, I'm going to use the series of the point, the first series on the circle, as the extreme 0, not as a pattern, as a extreme 0. And then second one, which is the one that is scaled and rotated, as the extreme 1. So now I have a series of, I have a new list. That new list, it has like 10 members between 0 and 9. And then these are getting weaved. So meaning that if I'm going to use a polyline in here, then I'm going to connect these vertices. So then I'm going to have like the connection between these 2 guys. So as I told you, if they're going to path, if they're going to go to pass these location of the first series, then you're going to have a funky shape as they're intersecting. So we don't want to have that kind of intersection. We want to have like somewhere between the 2 lines that we have in here, between the 2 points, sorry. So then also we need to close off this polyline. What we can do, either you can invert this close, which is right now is false, meaning that it's not closed. We need to make it true, which is going to be closed. Or you can use a Boolean toggle. So using Boolean toggle is going to help you to change this to true, and then connect it to this. This is going to get closed. Either way, but you don't use both ways at the same time. So either way. So that is the polyline that is getting connected all together. All right, we're going to next part. We would like to have like kind of a smooth line to connect these, although that you can use like the jagged lines later on, whatever you prefer, but I would like to use more of a kind of smooth line in here, and then that is the interpolation of the points that I have. So I have like all these lines of these points, and then using the vertices for the interpolation, and then this is going to get interpolated between these points, and then it's going to be periodic, like using the exact same Boolean toggle component, copy paste it, and then put it on true, and then connect it to this. Then this is going to get connected. This is going to get closed. So true and false. You can see it in here. So then now I can turn off these points, and also these weaved points, and also this polyline in here. So I have all these points in one list, and then they are getting interpolated, meaning that if I'm going to change the location of these, then you can see that, and then also you can see the scale can be controlled by these two sliders. So scale, and then also the rotation. Anyway, so let's go and then do a little bit more, and then that would be first of all extruding to see the shape, the actual shape of this lamp that we have. So extrusion, because for the workshop we used 60, I'm going to use 60 just for the sake of consistency with what we have done. So that is the base, and then the direction, you know that the direction is going to go up, so it's going to be z-axis that I need a unit z vector. So that is going to be connected to make a 60 unit. We talked about the unit, so in here we're going to use a decimal unit and then a metric unit in here. We're not going to, just like get to the feet, and then also inches. Later on we can do that for the 3D printing stuff, and then we can make a decision about that. So right now we have 60 units is going up, and then that is only proportionally considered just a number. Okay, so what we're going to do, we're going to turn off this. We don't need this. We need to copy paste in here. Well, let me give you a kind of note. In here I use a different method. I use that extrusion, then I use the contour to make a series of the contours in here, but I don't want to use this system because in the workshop I use move to copy paste, move, copy paste and move, just like as many of these profile that I needed. So I use this with series, and then if you remember, series is started with just like the start point from 0, number, like the steps and the number and the count. So I use the count, so 60, if you remember that, and then the step is going to be 1. I'm not going to change that, but I put between 0.2, 1, and 2, just for the sake of later changing purposes if I would like to do that. If not, I don't need it. So, and then the movement is going to be along z-axis, so that is the motion. And then what is the object? So the object is going to be this curve that we have. So that is the geometry that we move. We know that in Grasshopper we don't have copy, and then we have only array. We don't use array that much. actually be honest with you, so we don't use that. Mostly we use like different types of methods. So now we have movement, and then if you see the list, so the list is going to be 60 items between 0 and 59 indices between 0, as you can see in here, starting with 0 all the way going to 59 indices 59. That's the index 59, the last one. So meaning that we have like 60 geometry, 60 object in here. All right, one more step is rotating these geometries, rotating the slices of the geometry that we have. So instead of getting to the each of these geometry centroid, right now we don't need it, so we can use the centroid for like a 0, 0, 0 as the centroid. Still we can rotate around that, meaning like a kind of axis that we have in here. So what we need to do is just using the same series that we have in here, the same number of the count number that we have. Then the steps would be different because we have like the steps there, the number of the rotation. So I would like to, like the amount of rotation, sorry, not the number. Then disconnected, control, keeping and then holding control. And then now I can use this step at like, let's say between a -5 degree, -5 degrees to 0 to let's say 10 degrees. I don't know. I have no idea what's gonna happen, but we will see. So then the start point is gonna be 0, so meaning that we're gonna have like probably with the increment that we can see in here, we're going to have like a starting from 0 with the increment of 3.2, then for 60 times, which is like index 0 to 59, the 59. All right, okay, good, cool. So we have like 60 times of rotation of this, and then this is going to be our geometry, this is going to be our angles, and then the plane is going to be 0, 0. So I can now turn off this geometry, and then that would be our beautiful shape of our lamp in here. And then we can start playing with this number if you want, but right now, because we didn't just like change the actual unit in here, so you're gonna see some anomaly because we didn't change our unit in here. You see some anomaly when we are gonna move in here. Anomaly as for the increments that we have in here. So now again, radians, and then again degree to radians would be a better way to control the amount of rotation this way, so it's not jumpy anymore. So we can see that is really nice and beautiful. So you can increase this number, double click in here, and then you can go all the way to whatever number that you want to see more rotation, more of the rotation between the different profile that you have in here. And then let's get a kind of sense of what's going on by getting a loft, and then using loft and connecting all these to this loft. This is a geometry that we have. Then we can decrease this number to see actual geometry that we have in here. Nice and clean. I'm going to turn off all these points that I don't need anymore. So now it's the also this rotation, and then it's going to be just the form of my lamp in here, and this is x, y axes. Those are both axes, they're here. All right, okay, let's move to the next part. The next part is going to be manipulating the scale of these profile that we have in here. In my previous example, I used both the rich graph mapper and then also the graph mapper, but because some of you guys probably don't have access to rich graph mapper because you don't know how to download those and you're new to this, I'm going to use graph mapper, but be aware that rich graph mapper, mostly it's better because of the control that we have on the source and the target numbers. It's going to be easier, much easier, and then you can do more with that comparing to the simple graph mapper that we have as a default component with coming with Grasshopper. So we're going to use this. This is what we're going to do. We're going to have like scaling. We're going to scale these profiles in here. Also, because we have like the rotation of these. First of all, we need to scale at the end. We need to scale. So how we're going to do this scale? It's going to be based on the location of these geometries. All right, so we need to find the centroid for these geometries because we need to scale each of these profiles based on their own centers. So there is a component, you know that, it's area. So we're gonna get area from each of these 60 section that we have in here, and then we're gonna have like 60 centroid in here. And then also we would like to start working with data scale factor. To do that, we're going to have like deconstructing the points of each of these centroids. So we're going to deconstruct that to arrive at z, and then based on this z, we can start working with the scale factor, the scaling factor for these geometries. All right, so how we're going to do that? So we're going to use these points. These points, we don't need the area. So these are the points, x and y and z. X and y, we don't need x and y because both of them they're 0. But we know we need only z numbers. So these are the z numbers that we're going to use those to put it into a kind of scaling system, a scaling factor. So the centroid is going to the center because for each of these geometries that we have, this is going to be center. So this is the geometry. So of course the geometry is going to get connected to geometry. Geometry to geometry. Now we have like each, because by default the scaling factor is 0.5, we have each of these sections scaled down to 0.5 of those geometries. Now we would like to work with these scaling factor to have them control parametrically based on the number that we're going to get. So let's just start with something in here. So what we need to do, we need to set a graph actually. So we're going to set a graph. Let's just start with the sinus. I really like the simple sinus. Let me see if I can find it. It's going on the other monitor of mine, so now it's good. So we're going to use the sine. So we're going to use this, and then we're going to start playing with this number. So I have like the number between 0 and then also 60 because I have like, I put, if you remember, I put the height on 60. So I'm going to use between 0 and 60. And then the scaling factor, I'm going to put it between like something around 0.3 and then let's say 2. That would be interesting. Okay, so meaning that whatever number that I'm going to feed this, we're going to scale those based on the number that we have, and then we're going to see some type of, just like scaling factor that we're going to feed it to this scaling. That is really nice, actually. It came out really nice even with the first try. So I think that's good. So you can play with this. Also, you can play with this location, bring it down to minimize the effect, or you can radicalize the effect by doing this. Would be more like kind of vase or vase type of shape and geometry. Interesting. And then now you can move your loft actually in here and then connect your loft to see what's happening, and then turn it on and turn off the rest of your geometry definition. And then also this one, you don't need it. So now we have a kind of vase sort of geometry in here, and then of course you can play with it and then see what type of setting that you want for your sections. But be aware if you're going to work with these numbers, and then if you're going to change, for example, the height of your lamp, so you need to work with these numbers, and because these are not remapped, so these are the actual numbers, and then these are the actual scaling factors between 0.3 and then 2. Those are the absolute number that we are using. The difference between the graph mapper and then a rich graph mapper is in the rich graph mapper, you can rescale the numbers, but in here you need to work with the actual and absolute numbers. All right, okay, so we're almost there and then almost done. Okay, last step. So I'm going to turn off this. I don't need the shape of my vase or lamp, sorry. And then what I need to do, I need to extrude these, extrude each of these sections. But how much? I mean, like, first of all, it's going to be unit z vector, but how much? We know that it's 1, but if you're going to change this distance between them using this guy, then I'm going to connect this number, this, to make sure that changing that number is not going to affect the amount of the extrusion, and there is no there wouldn't be no gap between these two sections if I'm going to change this number now. So there is no gap. If I have a different slider in here, then they're not going to work together, and then always there is a kind of lag. I need to get back again and then change this to make sure that there is no gap or no overlap. If you're going to make it smaller, it's going to be overlap. Alrighty, okay, so let's do the last step, and it's going to be very processor consuming, but we're going to have like a kind of offset. There are two types of offset geometry. And then let me see, yes, offset surface. This one is from pufferfish. That is kind of, just like component that you need to download it if you would like to use this. Otherwise, just like you need to use the default component for the offsetting the surface, and then that is the offset surface. But this one, this offset surface, it has like more capability. That's why I use this more. So how you're gonna download those components that you want and then plugin that you want and or you need. So I have like some tutorials, so you can watch those tutorials, and then it's easy. Alrighty, okay, so let's go and then finish this before sending it to the 3D printer. So that is going to be extrusion, and that is my surface, and then how much. It's going to be a distance, and then that is the distance that we want. Right now, by default, is 1. But I'm going to make this along the distance. I'm going to make it like 1.5, just to give you a kind of idea that we have the distance. And then it's not going to be both sides. It's going to be only one side, not both sides. And then if you would like to make it both sides, so you need to mess with this number, because right now it's 0, so you need to change it and then create solid. Yes, true, because I would like to have these solids. So the last step, so it's well, let's, before getting to the last step, so we can start playing with changing some of these, but make sure, because right now we're using the offset surface, is going to be very, very heavy calculation for your processor. So you're going to have like some sort of lag in here when you're moving things, and then it takes a while actually to respond back to what you were doing. It's not going to be as fast as beginning of your definition. So if you would like to get rid of this laggy before, you know, just like by changing and then experimenting with the shape and form of your lamp, so you can disconnect this and then turn on this. It's going to show you the form, and then you can play with this form easily. Then at the end, let's say this is the form that you want, and then you're happy with it. Of course, that you can also play with number of the divide too. Look at this. Now we're getting more and more beautiful type of forms. So now you can say that this is a form that we would like to work with. And then now is the time that I can connect again this to surface. It takes a little bit of time to run this. Then I can turn off this extrusion, and would be the last step, so it takes a little bit of time, so you know that. Oh yeah, that's good. So I'm so happy my processor didn't get completely burned actually. So now I can bake this by right click on this shape and then bake. You can put all of them together as one geometry by clicking in here, put it on layer 5. I would like to put it on layer 5. Then this is baking. The geometry is going to be ready after baking to send it to the manufacturing. Either you would like to do something with like laser cutter or 3D printer, so I can record a separate tutorial to show you how you can have your own geometry set up for the 3D printer, and then what kind of details that you need to know based on what we have at the school, and then the 3D printers that we have. So that is a geometry, the final geometry of our lamp. Hopefully you learned this. If you need any sort of additional explanation or something like that, so then please let me know, and then later on we can discuss that, or you can ask your question in the comments of this tutorial. Good luck.